Hi everyone, welcome back. And today we'll do this question called string compression. And it's a medium question, but it's in fact just a combination of many other medium to easy questions combined together in one question. And hence, it's rated as a solid medium. But I'll read the question and explain my thought process and how I get to the answer as quickly as possible because I don't want to make this video too long. So given an array of characters, we are supposed to compress it using the following algorithm. So they are saying we should start with a string, empty string S, and for each consecutive repeating characters, we perform the following things. So when we see repeating recurring alphabets, recurring objects, if the group's length is 1, we just append that character to S. Like if it is something like just A, we just append A back to the final result. But if otherwise, we append a character followed by the group's length. So if there's A and A, we put A2 like this. AA becomes A2. So that is one part of the question. The next part of the question is that the string shouldn't be returned separately, but instead should be stored in the input character array, which is the input array. So they want us to dynamically modify the character array, either while doing the first traversal or the final stage or something. Like basically we need to return, not necessarily return, but we need to modify the input array. If we don't modify the input array, the debugger will pick it up and say that we didn't edit the character array. And note, for group lengths that are 10 or longer, the digits must be split. So if it's 12, it needs to be split into 1 and 2 into the character array. So that's another part of the smaller subtask in this question. So first thing is must do the counter. Next thing is must modify the input array. And then next item is that it should be split into digits, like 1 by 1 and put into it. And the last section is that we are to do this by modifying the input array. We are not allowed to create a new array, and we need to return the length of the new array as our result. But basically, we cannot create a new array. That means we will be only using constant extra space. So these are all minor inconvenience, minor frustrations that has been inbuilt into the question to make our life slightly harder. But if we break it down in sequence, it's not exactly hard. So let's look at the case studies, the test examples that they're given. So in this example, we have AA, BB, and CCC, A2, B2, and C3. If it's just A, we'll just return A. If it has A and 12 B's in a full row, we put A, then B, and then 12 gets split into 1 and 2. So you can see that this whole thing, as mentioned, has a few different parts. So we will target them in sequence. So first thing that we will tackle is how do we do the counting of all the objects in the array? So to do that, I will want to do this in one swift motion, which is in one for loop array itself. I would want to finish the counting of the whole process. So for ij in enumerate characters, I see if j is equal to cars I minus 1. That means if it's the same as the previous one. Actually, I can help myself by doing this. I'll first put the previous one as cars is the first starting item. And if j is the same as the previous item, I add something to count. Count is another variable that I would have to create. And I'll start count with 0 because I'm starting from the absolute beginning when I use enumerate. Like when I'm saying enumerate, I create a object that looks like index and object, that kind of a combination. So it'll be like 0A, 0A, 1A, 2B, 3B, 4C, etc. So I will reflect the index and J will reflect the object. So if the object is equal to the previous one, we increase 1 to the count. And if it's not the same, that means if it's not identical to the previous one, then we have to we must know that we have gone to the next group already. So A will start at 0. It will see A first, and then it'll add 1. So count is now 1. and then go to the next item, then count will become 2. And then when we go to the next item, it'll be different. So it'll fail this, and we need to append our findings to S or whatever different things. So this is where I think I will add a twist, or not say twist, but like I want to add some optimization while coding in the first round itself. What I want to do is I don't want to create an object called S. I just want to modify the character as soon as I see it. So this method is fine because A and A, if I only need to keep track of it if the count is actually bigger than 1. So if the count is bigger than 1, if the count is 1, I just need to return A like this. I just need to append A to the first item. If it's more than 1, I can still append the item, but I just need to replace this alphabet with the count of it. So at minimum, it'll be 2. I'll just put 2 here. I'll just replace this value to 2. At worst case, it'll be like maybe 11 or 12. But if it's 11 or 12, that means we have 11 or 12 A's like this. Like we'll have 12 B's over here. It doesn't matter if I adapt B and then adapt these 2 values. Like we would have definitely more than enough space for us to modify these items. So how do I know where exactly to replace in place for the array? So this is called in place modification. So to know how to where and how to modify, I need to keep track of the current index, and this will be useful at a later stage as well. So let's say the starting point for the first value that we must do an in place replacement is index 0, because that's where we need to put our first item in. So the first item, I'll just keep it as index 0. And so if it's not the same, I need to replace the item at index 0. So cars index, so wait, before that, I need to take note of, I need to make sure the count is, if it's 1, I need to handle it in a certain way. If it's not 1, I need to handle it in a certain way. So if it's 1, what do? I just take cars, go to the present index that I need to modify, and I put in the previous alphabet, which is A, B, whatever. And I don't need to keep track. I don't even need to consider like, oh, what is the digit? Like, how long is it? Because it's just 1. And if it's just 1, we just return the alphabet. They don't expect us to put alphabet and then 1 next to it. So after that, if it's not 1, what do? We do the same thing. We need to index is equal to previous. We still do the same thing. Oh, I forgot something. The previous one, like after we modified this first element to be whatever that we want it to be, like we need to increase the index. So something like this. And cars index equals to previous. Yes, correct. So far we change whatever item, whatever index that we are on to this. And we do need to do index plus equals 1, because the next item that we're going to see that we need to replace is the digits. Like if it's 1, we need to put 1. Sorry, if it's 2, we need to put 2 here. If it's 12, we need to put 1 and 2 here. So how do we do that? So for that, I'm going to employ like a for loop to look through the string of the count. So the count will increase because as long as it's the same as the previous one, it'll keep increasing the count. So count plus 1, count plus 1. So it'll be like B will be all the way until here. Only after it sees that the next item is not the same as itself, then it will exit and go into these things. So now, if cars is equal to cars, and we set it to the previous, then the next one is I'm traversing through the count of the items. So I'm basically extracting the digits out of the count. And I basically modify the index again with the digit. And I will update the index once again. Every time I update the finale, the cars input thing, because I need to make sure that the next item that is placed will be next to it and not on itself. Like just keep replacing the same spot. We don't want that situation. So hence cars index S and index plus 1. So this itself is mostly okay. So remember I mentioned that the index will come in handy for us because in the end of the day, we just need to return the length of our items. Like what is the length of this? We don't need to return the length of the whole thing. It's just the length of the items. And since we are keeping track of where we are finally placing and replacing the thing, for instance, the index will be at 4 because it'll be 0, 1, 2, 3, and the next item that because we are adding one more to it, right? Like it will point to this like a fifth item, but fourth item, fourth index. But if we are to do a length of the existing array, it'll be 4. So the fourth index is in a way can be used to define the length of the array that we have built so far as well, because the starting point of Python array index is 0. So we can just return index, and that will be our answer. But that being said, this question is still not complete. It's mostly done, but it's still not complete. Because remember I mentioned that we only exit if the next item is not the same. If this item, like for instance, A, it will only terminate if the next item is not the same as itself. So for this sequence, B, 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 it will not even exit because it doesn't have a next item to jump into to reflect what is the count. So how do we come around this? Like if we run this program right now, this sequence will just return us A because B never exits. B will keep going through this loop and it'll just terminate itself because it's the same as previous. And we need to make sure that it sees a change. Like only if it sees a change, it will terminate itself. So that's where what I suggest is modifying the cars array at the start itself. We create a situation where it will terminate. And this is by all means fair and legal. Like there's no issues with creating or modifying the input array to suit your purposes. So this is how I will modify. I will create like some string. It could be anything. But since they mentioned that all of it is a letter, an uppercase letter, digital symbol, I will just put a word here because nothing will be similar to this. Like no object will be similar to exit. Hence, at the end of it, like after it traverses through these 12 Bs, when it goes to the next item, it will fail this condition. It'll go here and it will update the characters count of B and everything. So with that being said, I think this question should be done. I don't think there should be any other mistakes or like any issues. What is it? Previous. I think I spoke too soon. Let me just check where the issue is. Okay, so when we do see something new, we need to adapt. We need to modify what is the previous. Like the previous cannot stay as the same A. Like I can't believe I missed that. But basically, the previous has to change. And where does it change? It changes somewhere here. If it's not the same, like as in if it's not the same as the previous one, so previous will become character and I. Sorry. It'll just be J. Yeah. Previous will become J. Hopefully this solves it. Still not. And count will become 1 because it has already seen it. So count will become 1 over here. So this is the modification that's required. So yeah, let's submit this. The reason why count is 0 here and 1 here is because like when we start out, we are counting for the fact that we will be seeing this initial item again. When we do enumerate cars without omitting the first element, we are accepting that we will be traversing through that element again. Hence, I offset it by putting count is equal to 0. But when we are going to the next one, when we finish this, what we are doing is we are saying that we have seen it already, count is already 1, and we are going to the next one, and we are seeing if the next one is similar to, like, when we go to the next one, we're trying to see if the next one is similar to the previous one. So the previous one has to be changed to A. The previous one is changed to A. In this case, the previous one is changed to B. And the count is already 1. And when we see the next one, we're going to compare it against this to make the change of count plus 1. So in that case, count plus 1 must be starting from 1. So 1, then 2, and subsequently. But over here, we will be seeing this again and comparing it against itself. That's why we start from 0 initially, but start from 1 subsequently. And that's how we achieved our results over here. We beat Python users by 91.6% and memory space by 97.68%. Because we didn't particularly create any new arrays, we are just modifying it itself. And by putting end and everything, we are able to get the optimal results that we wanted. So yeah, sorry for the careless mistake over here. I didn't spot it, but it's normal. Like, you don't need to get it perfect the first time that you code. And I will try to keep my videos shorter and more streamlined next time. But hope you guys enjoyed the video and let me know if there's any other things to improve, and I will see you guys in the next one. Thank you.